Okay, guys. Um, Last science Zoom course for fourth quarter, sixth grade year. Um, just a couple things for this week, housekeeping issues. Make sure if you're missing work, you can still get that in, at least for partial credit, if it's not super late. About half of you are missing work, which is not a very good percentage. I know this isn't uh, what we wanted for this quarter, but all the work that you were given you're capable of doing and doing well. So please do that. If you hand it in, submit it, it'll send me an email and I'll grade it before next Wednesday. Everything is due next Wednesday. So if you look down here, we have a survey that we're going to load up. That'll be due Wednesday. Um, and then this week's, your assignment is just an energy cells presentation. So we're going to present the last three forms of energy today. They're all inexhaustible in a way. Um, there's really only kind of two truly inexhaustibles, and that's hydro and geo. Wind and solar are inexhaustible when they're there, but not all the time. And so, um, so our objectives is we're going to describe inexhaustible. We're going to list those types, discuss the positive and negatives of all of them, and then kind of just review all the sources really quickly. I'm going to pull up this blank cells presentation in the rubric and look at, and I'm going to show you an example that I made up of oil. You can't pick oil because oil is not used for electricity generation in the United States. So I did that example for you. You can't pick oil. You can pick coal, you can pick natural gas, or you can pick any of the other ones, nuclear, non-renewables are those three, and then all the renewables. So daily question for today is list the inexhaustible energy sources. And so what are inexhaustible? Well, like I already said, the two truly inexhaustible are hydropower, because of the water cycle, and geothermal, if it's set up correctly, it's not going to overuse the heated underground water. It's just going to keep re-injecting that water back in to get it reheated. Wind and solar could be considered that, but once again, it gets dark or the wind doesn't always blow. So here it is. Biomass is renewable. We have hydropower and geothermal, the two truly inexhaustible, and then wind and solar when they're there. And then here are our non-renewables. Remember, oil is really only used for transportation. So when you look at this energy source here, you don't really see oil on there. Petroleum at 0.7, I guess. So just not much because it's really dirty to burn. All right, so let's get into the other power sources. So energy is created with using hydropower. It's been used for a long time. Um, we used hydropower way back when for these mills. They were called water mills, and so they would mill grain, they would saw wood, they would just do all sorts of things because it's mechanical energy, so it moves things. Okay, and then we have wave energy, we have tidal energy, and we have dams, and so those are the three examples for energy for electricity. Okay, so how does it work? Same thing, we're going to be spinning turbines, okay? And it's going to produce electricity. Water is better than wind because it's got more density, so it takes less, um, how do I want to say that? So I could get more energy out of like a 3 mile an hour river than I could a 30 mile an hour wind because of the density, okay? And so, uh, what do we used to use it for? Crushing ore, grinding grain, lifting, all these different things. If you look at this mill here, and then if you look here, it just shows other things happening. And so it could crush ore, bam, bam, bam. This one here looks like a sawmill or a grain mill. And so just all different things that it could do. Okay. Now, what are we using for today? Well, um, we put a dam, we build this huge dam. It builds up water behind it. We let the water through towards the bottom. And so if you look at here, this is where the water comes in on Hoover Dam, these four towers that are out away, and the water comes in down here. This is the power plant in the bottom. And so there's all these turbines in here, and so these tubes flow through the rock wall, they come down and they get let out, They can control the amount of water that goes in and out. And so in the summertime, they're flowing like crazy because it gets super hot down there, and a lot of people need electricity for air conditioners. And then people are using the water below for irrigation too. So dams are good for a couple purposes. Um, this was something we would have done if we were in class. We fill up this big metal tube we had, and these are corks. And so just kind of make a prediction really quickly of which one you think would flow furthest out and the longest. So if we fill this all the way up, we pull cork A. We fill this all the way up, we pull cork B. We fill this all the way up again, we pull cork C. And so when we pull B and C, we'd put A and B back in for C, we'd put A and C back in for B, and then for A. And so what you may have done is you may have predicted that A might flow the least, C might flow the most. And so if you look at how dams built, the dam's built where the inflow is going to be somewhere over here, but where does the water go out of the dam? Towards the bottom. Because you're going to have all this pressure from the dam that's pushing out. And so when we pull cork C, it runs the longest, so the time, it has the biggest around flow, and then it flows out furthest from the actual cylinder. So that's just something that we would have done in class for an example. Okay. All right, and here is wave energy. And so we always probably think about surfers or tsunamis or something when we think about waves, but in Spain, they did this thing, it was called the Salamis Wave Factory. And so these waves would go back and forth like this. And so if you've ever seen those flashlights that you shake, that magnet goes back and forth in there. This is the same principle with this. And so it just goes back and forth, back and forth. Let me see if I can get this to play a little bit here. But, and I'm gonna, yeah, okay. So there it is. Okay. So, so that's what it does. It just kind of goes back and forth. And so they tether it down. Um, you know, ocean waves are powerful, but they just rock back and forth, and it's going to create electricity and send it back to the shore. Um, and they're doing, I mean, this is minimal environmental impact, but they still need to do a study on it. So wave energy obviously wouldn't do us much good in Wyoming either. Okay. Tidal energy is the same thing. In America, we don't have very much fluctuation in tide, and so it needs like, I can't remember what it is, but I think it's something like 14 or 15 feet difference in tides, and we just don't have that in America very much. So, like Maine has that, and Alaska. So Maine and Alaska could have tidal power. I think there is a couple on Maine that are built, but even even with shorter tidal power, so like where my family, some of my family is in New Jersey, and there's like a 6 to 8 foot difference in the tide. If they could figure out how to get these tidal turbines in there, where it's pushing it as the tide's coming in and pulling it as the tide's going out, that would work. But something like this with like a tidal fence or a tidal barrage, you would have to have a way bigger fluctuation. Maybe not so much a tidal fence because it's spinning like this sideways. Um, but this is kind of an interesting film. A lot of this is still just theoretical, or they're just trying, and it's super expensive. Seawater is powerful and it's salty, and so it can just eat away on things. It's kind of corrosive. So there's just lots of things to consider. But this tidal barrage in France has been going for years and years, and it's generated gigawatts of power, which is pretty awesome. And it's in La Rance, France. So they capture the water and then they release it like a dam, and it's really good. All right, so pros and cons. It's reliable, it's inexhaustible, there's no pollution or carbon emissions, there's no downtime like solar wind, and reservoirs are good for recreational use. The problem with dams is it can destroy natural habitat, or tidal fences or barrages or anything like that. You're going to disrupt maybe the natural environment a little bit. Fish migration. They've started making fish ladders, is what they're called, so fish can actually just jump, 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 and keep their migration routes, but they didn't do that with lots of the older dams. So some of those have messed that up. They can displace people. Um, when you build a dam, it has to fill this huge reservoir behind it. Um, there are a couple old sheds and houses in the Boysen Dam area, but you can't see them because it's so deep right by the dam. But before they built that dam, they did just abandon a couple of those things there. And then Ocean Lake, I believe, has like a barn and a corral in the bottom of it. You can see that if you fly over. So Ocean Lake's really not a dammed up one. It's just an agriculture one. But those are a couple things that are pretty close to home. So can displace people. And then droughts, obviously, are a problem. But one thing about a dam is that it can actually help with droughts too. So yes and no on that as a negative. Okay. And then wind. Wind energy, obviously, in Wyoming is some pretty good energy. Uh, Same thing, it's using the mechanical energy of the wind to spin a turbine to create electricity. Okay, and so here's just kind of some history. They've used wind for lots of stuff, and so sailboats along the Nile. That was um, the ancient Egyptians. We've seen maybe with some of the other tribal people in Indonesia and stuff how they've just had that around for a long time. They started using pumps in China, in the Middle East. In 1100, they made the first windmills to just pump the marshes, and so they um, Denmark is actually below sea level, so they um, pumped that out and made it into farmland. And then obviously when you think of windmills, you might have seen some of these or some of these. And so those are used for, like this was a sawmill, I think, and these are used to pump water. But wind turbines started to be developed after electricity was being used because out on the farms, they didn't want to pay for all the electrical lines to get out there. So they had generators and windmills or wind turbines. Okay. All right. And so here's how it works. There's the gearbox. It's going to spin this really fast. So this spins actually really slow. If you've ever seen them, they spin really slow. But if you ever had Lego robotics with Mr. Salisbury, you know that if you take a big gear and put a small gear on it, it's going to spin this like super fast. And so that's what happens. Generates electricity. Electricity goes to the transformer. It's transformed and sent down the line. Okay. And then Wyoming wind. One of the highest wind energy potentials is Wyoming. And so if you look here, this is kind of a map of where it's good. And then the blue it says superb. And so if you have ever been by Cheyenne and Laramie, there's quite a bit of uh, windmills down there. And then any of the pink is good. So there's quite a few around Rock Springs and Green River, Evanston. The problem with that is like wherever the wind would be good, there's also beautiful mountains, and people don't want those big old ugly white wind towers obstructing their view from the mountains. So, um, positives: inexhaustible, no pollution, carbon emissions. The operating cost, wind is free. And that's kind of misleading in a way because those towers are super expensive. Um, Land with turbines can be used for farming and ranching. They have a really small footprint, is what it's called, and so they have to dig down and pour a lot of concrete and everything because it's like a tree. Like 2/3 of the tree is underground, and so same with the windmill. Like 2/3 of the mass is underground because it's got to hold up that big thing when the wind's pushing on it. So um, and that's saying that it doesn't produce carbon dioxide and other pollutants. You have to mine iron and those kind of things. So yes, it does a little bit, but not actually to produce electricity. And so they're very noisy. They're getting a lot quieter. Visual pollution was something I already talked about. Wind doesn't always blow, and then it is the expensive upfront cost. They can kill birds, and I wrote in parentheses, it does not last that long though, because what they found is when they initially put the wind turbines up, there's quite a bit of bird death and bat death, but the bats and birds figure it out fast, and they um, adapt to those things being up. Like if a tree would grow, and they would figure out that that tree was there pretty fast and not fly into it anymore. So um, they're smart. Last energy is geothermal, and this one's kind of the coolest because it's super efficient. And so once they set this up, it's the most highly efficient energy there is out there. And it's set up where they bring up this hot water, they flash it a couple different times, they spin the steam turbines, creates lots of electricity. The steam goes out the pipes, and it's just H2O, so it's water vapor, and so it doesn't have any negative effect. Sometimes it does take quite a bit of land. Um, Compared to like a windmill or something. But and then what do they do with the warm water? They inject it right back down in to the same well that they got out of, so that water gets back up to the superheated temperature again, and so it's inexhaustible. Um, but you can't overuse it, and you can't overpump because then it would cool down, and then it wouldn't be as effective. And so these are just some examples of temperatures and those kind of things. And so, where does geothermal come from? Geo comes from the earth. That's what geo stands for. You guys remember that from Miss Roseberry, hopefully. Okay. And then this is just a kind of a simpler version of what I just talked about. Hot water comes up, goes through the process, it gets injected back down. It's going to get heated again before they pump it back up. And so it's just continuous, inexhaustible. And then we have direct heating systems, which are used in house. So that's another advantage of geothermal is um, you can use it for more than just electricity. So my aunt and uncle have a house and they have geothermal, and so the pipes run through the floor. It's pretty cool, and it's like their well is 62 or 63 degrees. So in the summertime, it's like a really good air conditioner. In the wintertime, they only have to heat it up just a few degrees to keep their house warm. Okay. All right. Negatives. Let's go over those first. So the negatives are greenhouse gases and some toxic chemicals are found. So as they release that, sometimes those, um, as they drill the well, some of that will be released, or as they're releasing some of the steam, there might be some sulfurs or something. Um, Hydraulic fracturing can be used to try to find these hot water wells. It, they've kind of gotten away from that. It's very location specific. So if we go back to here, you see that these are only where you find geothermal because there's not much in the whole eastern coast. Where do most of the people live? Right along the coast in here and over here. So it does good on the west coast, but not so much over here. Okay. And then uh, even though the heat of the earth is inexhaustible, we can deplete the reservoirs, or if you use them too much and don't allow them to reheat like they need to. So, but they're super reliable. They have lots of energy stored in the earth. They're great for heating and cooling. So in the wintertime, they can cool. And just some really cool, really super efficient. And then what some of the plants have done, like in Utah, is they, when they do steam it out, they actually capture the salts and they can sell those salts and sell like zinc to vitamin companies to put in your multivitamins, or like we use it in cow supplements. So, all right, and this is from 2015, so this is like 4 years ago. They could probably have 2019's compiled by now, but sometimes they don't get that out there very fast. And so here is our dependence on energy, and so renewable is only 10%. It's actually, I think it's went up to like 13 or something this year, is what I read, 13 to 15. But hydroelectric's a quarter, biomass is almost half, and then you go smaller, smaller. Geothermal is super small. Remember, it's very spot specific. Okay, and in Wyoming, the disadvantage of that is where we have our good geothermal. One of them's a national park, and the other one's a state park, like in Thermopolis or Yellowstone. So, all right. So here's the deal. Your sales presentation is due Friday. I'll go over that here in a second. The survey that we're going to put up is due next Wednesday. So you do have an assignment due this Friday and next Wednesday. Last day of school is next Wednesday. Monday is off, so we won't have another Zoom. I know that disappoints you, I'm sure. But, so here's an example. Okay, move my head up here. And so I just did oil. You cannot choose oil as one of yours because we don't actually use that. All right. And so let me actually get out of this for a second. Okay. So here is your blank sales presentation. So we're going to give this to you. You're just going to type in all the stuff that you need in here. And here's the rubric. So The sales hertz with 5. The information, what type of source, where can you find it's worth 5. What's good about it, we're 6. So here's all of your different points here. So what you'll find out is the top part's worth 26 points, but your comparing and contrasting is actually worth 24 points. So it's worth almost half the points is just comparing your source to the other ones. Okay. And so that's where you're going to get the most of it. So if you look back at the blank, this big square is used for that. And so you can adjust that however you want it. But so that's the rubric. This is what it's going to look like. We'll load this up and you'll type in your energy source and put in all the information in these spots. You can adjust that and make it however you want. But so here is the example. All right. So we have, um, here it is. It says the slickest energy around. So that's my cell's hook. Okay, so we know that oil is slick. That's what it's used for. And so that's my cell's hook, slickest energy around. Okay, right now you can have this energy delivered dirt cheap. So that's kind of the advantage. So I have my sales hook and I have my sales slogan or sales pitch all in the same thing up here at the top. So that's worth like 10 points of it right there. Okay, I need to do a little bit better job and add like the price and actually how cheap it is down here. And so I did that. So right now it's under $30 a barrel. Okay, remember I have to tell me why it's good. Well, the best thing about oil, even though it is non-renewables, it's still very abundant in the United States, and they have found new ways to find it. So we've used hydraulic fracturing. They can use other processes to get oil out of shale and those kind of things. So they've gotten a lot big. It's used for more than just energy for electricity, and it's not really used for electricity in the United States. So that's why I said in underdeveloped countries, they will burn oil to create heat for electricity, but in the US, it's too dirty. We just don't do that. But we still use it massively for transportation. And so this is just a picture of a diesel engine. Um, here is one from, I believe, Saudi Arabia, Geothermal, and so they do burn oil and then they inject a lot of the stuff back down into the ground. So they don't pollute a whole lot. They've kind of figured out how to minimize the pollutants, but it's still more so than what we allow in the United States. Okay, and then here is my comparison. So why is oil better? And I just went and I compared them to all of the other sources. You only have to compare them to 6 or 7, 6, I think, 6. And so 1, 2, 3, 4, 5, 6, 7, 8. I put coal and natural gas on here. You guys can just compare to fossil fuels unless that's what you pick. And then all these other ones. And I separated out hydro and dams, and you only have to do hydropower as one. So you'd have 1, 2, 3, 4, 5, 6. Okay. And so fossil fuels 1, geothermal 2, hydro dams 3, solar 4, biomass 5, nuclear 6. And so coal and natural gas would be separated out. Okay, but you're going to pick one of those 8 or 7 sources. 1, 2, 3, 4, 5, 6, 7. You're going to pick one of those for your choice. Okay, so hopefully this is on the slides, and so this is the last one, so you can kind of refer back to this as an example, and that's just where you can do and what you can look at. So also just make sure you're using this rubric. It'll tell you exactly what you have. Oh, and so how does it generate electricity? That I actually used that picture for that. So this is how it's used to generate electricity. So maybe I should have put a caption of how it generates electricity right there. That would be good. So you can have more than 2 pictures. I don't want it to all be pictures, but if you want to add a third picture that shows how it generates electricity for that, that would be worth your 5 points. Okay. All right. Well, good luck. If you have any questions, email me or stay on Zoom today after this, or come to Friday office hours at Zoom. I send that email out on Friday mornings with that link. Get your work in, get it caught up, you guys. A lot of missing work. Like I said, every one of you guys can do that work. You just got to sit down and put the time in. Okay. All right. We'll talk to you later. And if you need help, please email or get on office hours.